In this segment, we're going to look into a practice problem on magnitude comparator. So the problem statement says, derive a Boolean function and a circuit diagram for the following comparator system that takes three 2-bit binary numbers as inputs, and the binary numbers are A, B, and C, and it produces the outputs in the following manner. So the system will take three numbers A, B, and C, and each number will be of 2 bits, and the output will be 1 if all three numbers are equal to each other. That is, if A equals to B equals to C, then the output is 1. Otherwise, the output will be 0. So pause the video at this point and try to solve the question on your own. A equals to B equals to C if A is equals to B and if B is also equals to C. So first we will check whether A equals to B, then we'll check whether B is equals to C. If both conditions are met, then only we can say that A is equals to B equals to C. So let's first check whether A is equals to B. So if you recall, we check the equality of bits using the XNOR gate. So first we will check whether A1 and B1 are equal or not, and then we will check whether A2 and B2 are equal or not. So for A equals to B, we need to check A1, B1. So we will pass A1 and B1 through an XNOR gate. So A1 XNOR B1, and we will have to check A2 and B2. So A2 XNOR B2. So this function is named as X, and this will check whether A and B are equal or not. So here I have drawn the inputs of ABC. Since each number is of 2 bits, so for A there will be 2 input lines, for B 2 input lines, and for C 2 input lines. So first we will check whether A1 and B1 are equal or not. So A1 XNOR B1. Then we're going to check whether A2 and B2 are equal or not. So A2 XNOR B2. And then finally we will add these two functions and we will get whether A is equals to B, and the function of A is equals to B is represented by the variable, the function X. Next we will check whether B is equals to C. So the process is very similar. First we will check whether B1 and C1 are equal or not, and then we will check whether B2 and C2 are equal or not. So to check B1, C1, we will pass B1, C1 through an XNOR gate, and then we will pass B2 and C2 through an XNOR gate. And then we will add these two functions and we will check whether B and C are equal or not. So the function that checks whether B and C are equal is represented by the function Y. So this part will check whether A is equals to B, and this part will check whether B is equals to C. And finally, we will have to AND these two outputs to check whether these three numbers are equal or not. So finally, we will AND these two outputs. So final output is Z, which is equals to X into Y. And if Z is 1, this will mean that A is equals to B equals to C. That if Z is 1, it will mean that these three numbers are equal, and if Z is 0, which means either one of these outputs was, at least one of those outputs was 0. So if this, let's say if this was 0, this means B is not equal to C. So if Z equals to 0, then it would mean that these three numbers are not equal. So this is the final answer of the circuit, and this is the function of the circuit that will check whether three numbers are equal or not.